The challenge. A manufacturing plant comprises of multiple assembly lines, processes, people, and subcomponents that work together in orchestration to create final product. The quality of this product largely relies on the multiple components and their attributes that are brought together. It is critical that these attributes and components that make up the product are traceable. Traditional methods of manually tracking product linkages is extremely time-consuming and error-prone. Automated traceability solution help to capture, store, and manage product attributes and process flows at various stages of product lifecycle, which helps in improving operational efficiency and customer experience. Persistence track and trace solution built on the Appian platform is an automated traceability solution. The track and trace solution involves the following rules. A product supervisor, who is responsible for production speed and quality of products. A kitting user, who is based on the starting point of the assembly line, the kitting station. This user takes the orders from the warehouse along with the product kits for assembly. A station user works on the product, and the quality user is responsible for ensuring the quality of the assembled product. We'll start with the demo. The production supervisor provisions and sets up assemblies for different axles, drivetrains by configuring different set of subcomponents. Once the assembly process has been defined, product information such as subcomponents or bill of materials can be sourced from ERPs such as SAP. The kitting station is a starting point for the assembly workflow. This user is responsible for creating new entries for products that can be assembled by scanning barcodes attached to the subcomponents to record various details. These barcodes can be manually entered if necessary. When all the details have been captured, a unique barcode is generated by a system which are physically attached to the product. This barcode will be used by the station workers for a quick identification of the product being assembled. The kit now moves to the first station for assembly. In this case this is station 10B. The station user scans barcode on the product and reviews information about the product. Part of the assembly involves the use of a tool called torque runner. Data from the tool is captured by a PLC which is integrated with the solution along with using an IoT gateway. Once the assembly is completed at this station, sensor values such as torque can be retrieved and recorded, allowing the product to be moved along the next assembly station. The next station is 20C. At this station, we demonstrate a rework scenario requiring authorization by a quality user. Like the station before, once the assembly at this station has been completed, sensor values are retrieved and reviewed prior to moving the product along to the next station. The station user noticed one of the sensor value has exceeded allowable limits, which will require rework to be performed. The station user designates the item for rework in the system so that it can be reviewed and approved by a quality user. The quality user observes a notification of an item that requires rework. Information recorded in the previous steps is reviewed and observations are made of any unacceptable values. In this case, the deviation is small and the product is approved for rework and the product is moved along another station user. The station user performs the required rework and ensures product values are within the acceptable ranges and new values are recorded and the product is moved along the another assembly station until it has been completed. It then moves along to a quality user. The quality user receives the product for final inspection. The product configuration is reviewed in addition to any recorded values or logged rework data. Finding no issues, the product is approved for shipping to customers. Finally, we move to the traceability report. If the customer issues are reported, a quality user can use a product ID to retrieve a traceability report for a specific product. The report details various data elements such as station users involved in the product assembly, in the rework performed, etc. This allows issues within the assembly process to be identified and corrected. The track and trace analytics provides insights into the key production KPIs. The cycle time breakup chart indicates the percentage of time spent on rework versus good product assemblies. Supervisors can drill down on the rework and see which machines and sensors is contributing to most of the rework that is happening to take corrective actions. The rework KPI indicates the percentage of rework that is happening in the plant by machines and suppliers. Similar to above, the KPI trends indicates that since the system is implemented in June, there is improvement in cycle time and reduction in rejections.